Hello everyone, greetings of the day. My name is Alok Barik. I am from Department of Physics and Physics, Madanapalle Institute of Technology and Science, Dept University. And today we are going to study about the fundamental of circuit analysis. Okay, when we connect the different circuit elements like resistor, capacitor, inductor, diode in a circuit, then how to analyze that? How much current is flowing through the circuit? How to analyze those things? We will start. So we'll start from the basic, very fundamental things. How to denote a battery. Generally, battery is denoted by a small line and that a large line. Okay. Now here this represents a battery having some voltage or potential difference, suppose V. Okay. And this is the conducting wire, and which is connecting with some sort of resistor having resistance R. Now this represents the positive terminal of the battery, and this represents the negative terminal of the battery. By convention, the current will always flow from positive to negative. So the current will flow from this to this direction. But actually the electron, this voltage actually push, it acts like an electrical push that push the electron to flow. The electron will flow in this direction. But by convention, the current will flow from positive to negative terminal. This is the simplest circuit, which consists of a battery of potential difference V, and current will flow from positive to negative terminal, but the electron will flow from negative to positive terminal, which is having a resistor, of resistance R. Now from the Ohm's law, we know that the voltage is equal to current, and that is equal to Ri or IR. Now in this case, in this simple circuit analysis, we generally follow the Ohm's law, that is voltage across the two terminal, it is equal to the current times the resistance. But remember, resistance do not at a particular temperature and external things keep constant, these things will holds good. Now at a particular temperature, this equation is valid. Now suppose, how to know how much current is flowing through this circuit? How can we understand how much current is flowing through the circuit, or how much the potential difference or potential drop is there across any 2 points, suppose A and B? How can you know? To understand these things, we take the help of two instruments, that is called, one is ammeter and another one is voltmeter. By means of ammeter is a electrical, instrument by means of which how much amount of current is flowing through the circuit we can know. And using the voltmeter, we can know how much voltage or potential difference is there across any 2 points across this wire. Okay. Now this conducting wire, we generally assume that this conducting wire, across this conducting wire, suppose copper or aluminum, there is no resistance in this wire, which is having small resistance, but we neglect the resistance of the conductor. Okay. And if you want to find the potential here, everywhere this is same. The potential remains same everywhere along this wire. This is acts like a equipotential wire. Okay, suppose the voltage difference is 12 volt. Okay, we consider this side is having 12 volt, this is having 0. If I measure the potential here, it will show all 12 volt. If I measure the potential here, it is also showing 12 volt. If I measure the potential here, it will show 0, here also 0 volt. Because this is a equipotential wire up to here. This is also equipotential here. So everywhere in the wire, In the conductor, the potential remain the same. Now suppose if you want to know how much current is flowing through this conductor, suppose at this point, then we generally take the help of this ammeter. An ammeter is an instrument by means of which we can measure the amount of current flowing through the circuit. And one important thing is that this ammeter must be connected in series or in line with the circuit. The ammeter must be connected in series. We'll come to this, what do you mean by series connection and what do you mean by parallel connection after a couple of minutes. But the ammeter must be in series with the circuits. And the ammeter is designed in such a way that it is having very low resistance. Very low resistance. So that the current, it will allow the amount, all the current to pass through it. And we can detect the current, the amount of current that is passes through this wire by using this ammeter. But we need to keep the ammeter in series with this. Now if you want to measure the voltage across any 2 points, or we want to measure the potential difference or voltage drop across any 2 points, suppose A and B, in that case we will take the help of voltmeter and we'll keep the voltmeter in parallel. We'll keep the voltmeter in parallel with this circuits. And this voltmeter is having very high resistance. The voltmeter is having very high resistance. Take 2 points, two lead points of the voltmeter, keep it like that. We can measure what is the voltage drop across that 2 points. In experimental, we can do like that. And this voltmeter must be connected in parallel. So that's the fundamental things we need to keep in mind while dealing with these things. First, we need to know how much amount of current flowing through this circuit. To know these things, we take the help of Ohm's law, that is V equal to IR. V is the potential difference, I is the current flowing through the circuit, and R is the resistance. Okay, and how can we know the amount of current? We take the help of ammeter, which will connected in series. Okay, remember, if you connect the ammeter in parallel, then that short circuit. That will short circuit these things if you keep the ammeter in parallel. So it always be in series, and the voltmeter always kept in parallel if you want to measure the potential difference across any 2 points. Okay. Now next, what do you mean by series and parallel connection? Suppose let us consider a battery. And here we are having 3 different resistors, for example. This is the positive terminal, this is the negative terminal of the battery. Here this positive, suppose some voltage V is there, we consider this one 0 volt. Here potential is V, here also potential is V. If you consider here also potential is V, because this is a equipotential surface, here potential is 0, at this point also potential is 0. Now this resistor 1 is having suppose resistance R1, resistor 2 is having resistance R2, and resistor 3 is having resistance R3. And suppose I is the amount of current flow through this. Now in this case, if you want to measure the potential drop across the R1, some potential will drop across the R1, and that potential drop is suppose V1. Similarly, here to here also, across the R2 potential drop is suppose V2, across the R3 potential drop is suppose V3. Now according to Kirchhoff this rule, this total potential drop across this closed loop must be equal to this voltage, must be equal to V1 potential drop across the resistance R1 plus potential drop across the resistors V2 plus potential drop across the resistor V3. Now, if you see carefully here, only the current can flow, only one path is available for the current to flow, and that is called series connection. This is called series connection. Only one path is available for the current to flow. This is series connection. Now, when this kind of circuit is given to us, we can analyze it by substituting the equivalent circuit or equivalent resistance. For example, here this is the again battery. We assume that this is the V is the voltage of the battery, and this is the equivalent resistance, R equivalent. These things is represented like this. But we need to understand, we need to find what is the equivalent resistance of this circuit. Consists of 3 resistors in series. What is the equivalent resistance of the circuit? Consists of 3 resistors in series. And here the current will flow again like this. Okay. So we need to find out what is the value of equivalent resistance. We need to find out what is the value of equivalent resistance, because here V equal to, for this circuit, this whole circuit, voltage equal to current times R, resistance, equivalent circuit. Okay. Now in this case, V equal to IR. What is the potential drop across this? Because the same current is flowing through the circuit, it will be I R1 plus, what is the voltage drop across this? The same current is flowing, so I R2. What is the potential drop across this resistor? It is equal to I R3. Or you can write these things as V equal to I R1 plus R2 plus R3. I R1 plus R2 plus R3. Suppose this is my equation 1 and this is suppose equation 2. Now equate equation 1 and 2. If you equate the equation 1 and 2, then I R equivalent is equal to I R1 plus R2 plus R3, or that is equal to equivalent resistance of this circuit is equal to R equivalent R1 plus R2 plus R3. So every time whenever we see any sort of circuit and where the resistors, here first we will deal with the resistors which are in series. Next we will see what will happen when we consider the capacitor, inductor, diodes. Okay, when they are in series, when they are in parallel, then what will happen, how to analyze? We will increase the difficulty level one by one. Now whenever the resistors are in series, we simply add the total resistance, which is their equivalent resistance. Okay. Now for example, okay, let us first discuss what will happen in the parallel connection. So in series, whenever the resistors are in series, the equivalent resistance is just the sum of R1, R2, R3. If suppose there are 3 resistance, then it is like this. If there are 2 resistance, for example, if there are 2 resistance, if a circuit consists of 2 resistors of resistance, equal resistance R, that is equal to R1, R2, 2 resistors are there in series, then in that case R equivalent will be simply R plus R equal to 2R. Okay. Like that we can analyze the circuit. Consists of only resistors in series, consist of only resistor in series. Now suppose let us consider the resistors which are in parallel. Again, in this case, if you see, three resistors are there. This is the positive terminal of the battery, this is the negative terminal, which is having the voltage 0. Here the voltage is suppose V. This point is also voltage V. This point also voltage V. Here it is 0. Here it is 0 because this conductor is the equipotential conductor. So every point, if it do not have any sort of circuit element, then every point the potential remains same. In the every point the potential remains same. That's why it is called equipotential conductor. Now if you see carefully, suppose current, I amount of current is flow from positive to negative terminal, from higher potential to lower potential. The current is always flow from the higher potential to lower potential, from positive to negative in this case here. Now here current I is coming. Now at this case, at this junction, if you see carefully, the current have three different paths to pass through. The current have three different paths to pass through. You can divide the same current. Some current is passed through this path. Suppose I1 amount of current pass through this path, I2 amount of current pass through this path, and I3 amount of current is suppose passing through this path. Of resistor, this resistor is having resistance R1, this one is having R2, this resistance is having, this resistor is having suppose resistance R3. Now in this case, the current is having different path. But what will happen at this point? At this point, what is the voltage? Voltage drop across this is same. For all the resistors, suppose at this point the voltage drop is same. At this point the voltage drop is same. At this point also the voltage drop is same. So voltage drop across all the resistance here, R1, across R2, across R3 are same. Now in this case, if you want to find what is the equivalent resistance, you always try to find the equivalent resistance for parallel configuration. So you want to find what is R equivalent for this parallel combination. Okay. So first we need to apply what is the voltage here across this one. This is what I1, how much amount of current is passes through this resistor of resistance R1. Potential difference is same, V equal to IR, Ohm's law we need to apply. So what is I? V by R, V by R. So what is the value of I1 here? Because the amount of current flowing through different branch are different here in this case. Across the R1 or along the, through the R1, I1 amount of current is flowing. Through R2, I2 amount of current is flowing. Through R3, I3 amount of current is flowing. So total current is equal to I1 plus I2 plus I3. So you need to find what is the value of I1, what is the value of I2, what is the value of I3. Remember, the potential difference across all the resistors are same, because here it is V, here also 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 it is V, here 0, here also 0, here also 0. So the potential difference across all the resistors are V only, but current is different. Now, so what is the value of I1? It is equal to V R1. What is the value of I2? That is current passes through this resistor. It is V R2, because here also the potential is remain same. That is V and I3, this is equal to V R3. Now, so I is equal to V by R1 plus V by R2 plus V by R3, or or I equal to, take the V outside, 1 by R1 plus 1 by R2 plus 1 by R3. Suppose this is equation 1. Now, for this equivalent circuit, what is the current? What is the current flowing through this? Current flowing through this will be I V by R equivalent. I V by I R equivalent. We need to always make the equivalent circuit, equivalent resistance, equivalent capacitor. Now, this is suppose equation 2. Now equate equation 1 and 2, and we can get that R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is in the case of parallel combination. This is in the case of parallel combination of the circuit, consists of resistor, consists of only resistor. So in series case, we simply need to add the resistance, equivalent resistance in series we need to add, and in parallel case 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R3. So in the next we will try to discuss what we mean by Wheatstone bridge when it is in balance, because in Wheatstone bridge case neither the resistors are in series nor in parallel combination. So we need to have a different approach to solve that kind of circuits. So in the next we will see how to solve this Wheatstone bridge kind of things. Thank you.